Hello, this video is going to introduce you to the primary trigonometric ratios. Each of these trigonometric ratios is a relationship between an angle and some of the side lengths of a given triangle. And specifically, primary trigonometric ratios are relationships between sides and angles in right triangles. So we're talking about only triangles that have a 90-degree angle in them. So here's a right triangle, and I've labeled one of the angles as x. And if we were to define the three primary trigonometric ratios for this reference angle x, we do that based on the labels that we give to the sides. So in a right triangle, we always call the side length that's opposite the 90-degree angle, we call that the hypotenuse. And in this case, we're going to label the side that's opposite to the reference angle, x, we're going to label that opposite side as opposite. And the third side that's remaining, we call the adjacent, which just means next to. So this is next to the reference angle. So we have three primary trigonometric ratios: the sine ratio, the cosine ratio, and the tangent ratio. And they're defined as follows. The sine ratio of a reference angle, x, is equal to the ratio of the opposite side over the hypotenuse side. The cosine ratio of a reference angle, x, is defined as the adjacent side over the hypotenuse side. And the tangent ratio of a reference angle, x, is defined as the opposite side over the adjacent side. And depending on what information is given about a triangle, we can use any of these three ratios to determine unknown side lengths or unknown angles within a right triangle. So to start, let's say we have a right triangle with these side lengths. So this side is 8 units, this side is 10 units, and this side is 6 units. And we're going to have this angle here be a reference angle. I'm going to use the Greek letter theta as a symbol for an unknown angle. That could really be any variable. So x is often used as an unknown angle. Y could be used as an unknown angle, any other variable letter. And sometimes we often use Greek letters to represent unknown angles as well. So this is the Greek letter theta, and it's just going to be used to represent our reference angle in this case. So if I listed the three primary trigonometric ratios for the angle theta, the sine ratio for the angle theta, the cosine ratio for the angle theta, and the tangent ratio for the angle theta. Okay. Now, in order to list those ratios, we need to first know which side is the opposite, adjacent, and hypotenuse. So on our picture here, we're going to label those. So the hypotenuse is always opposite the 90-degree angle. So the 10 is the hypotenuse here. The opposite side is opposite to our reference angle. So that's the side length of 8 units here. And the third side that's left is the adjacent. So we know that the sine ratio of an angle is defined as the opposite side divided by the hypotenuse. So in this case, the opposite is 8, and the hypotenuse is 10 units. And we can simplify that ratio to 4 over 5, or we could write that as 0.8 as well. So the sine ratio for theta is equal to 4 over 5, or 0.8. The cosine ratio is defined as the adjacent side divided by the hypotenuse side. So in this case, the adjacent is 6 units, and the hypotenuse is 10 units. And again, we can simplify, and here we get 3 over 5, or 0.6. The tangent ratio is defined as the opposite divided by the adjacent. And in this case, the opposite is 8, and the adjacent is 6. So the tangent ratio will be 8 over 6, which simplifies to 4 over 3. Now, depending on which angle in a right triangle we use as our reference angle, the opposite, adjacent, and hypotenuse sides will change. So let's say, for example, that instead of using theta as my reference angle, instead I use this angle over here, which I'm going to call y. So now y is my reference angle. If I now label the three sides of the triangle, the hypotenuse is still the hypotenuse because it's opposite the right angle. But now, opposite the reference angle is this side length. So when I change my reference angle in the 90-degree triangle, I change the opposite and the adjacent sides as well. So if I now state the primary trig ratios for this angle y, we have that sine y is equal to the opposite over the hypotenuse. So in orange here, we've got opposite is 6, hypotenuse is 10, and that simplifies to 3 over 5. Cosine ratio for angle y. So cosine ratio is adjacent over hypotenuse. So in this case, the adjacent is 8, the hypotenuse is 10. 8 over 10 simplifies to 4 over 5. And the tangent ratio for angle y is the opposite over adjacent, which if we look at our reference angle, the opposite is 6 and the adjacent is 8, which simplifies to 3 over 4. Okay, so here's a practice question. You stand 30 meters from the base of a tall building and measure the angle of elevation to the top of the building as 82 degrees. What is the height of the building? So when you see a question like this, if a triangle diagram isn't already given to you, you probably want to draw that first before attempting to solve for anything. A diagram helps you very clearly identify the given information and what you need to solve for. So in this case, if we say that this is the tall building, we are standing 30 meters from the base of that building. So here's the base of the building, and I go out 30 meters. Okay, so at this point, I'm standing here looking up at the top of the building. Okay, so that'll close off the right triangle. We want to solve for the height of the building. That's what this question is asking about. What is the height of the building? So I'm going to label that height with the variable h. And it also mentions this angle of elevation. Now, when we talk about an angle of elevation is always an angle measured from a horizontal line. So if I start from a horizontal line and measure upwards, we call that an angle of elevation. So in this case, the angle of elevation to the top of the building is 82 degrees. So if I start from the horizontal and measure up, because that's the definition of an angle of elevation, that angle will be 82 degrees. Another definition that is related to this that you want to look out for is an angle of depression. So an angle of depression is the opposite to an angle of elevation. It's starting from the horizontal, we measure an angle in the downwards direction. So this would be an example of an angle of depression. Okay, so we have our diagram. We have that our given angle is 82 degrees, so we're going to use that as our reference angle. And we have these two, well, we have 30 meters as one side length, and we have h, or an unknown side length for this side. So at this point, we need to figure out which of those primary trig ratios we could use. Okay? We can't solve for h using Pythagorean theorem, which is another tool that we can use for right triangles, because we don't have this length of the triangle here. If we had this length and the 30 meters, then we would be able to use Pythagorean theorem to solve for h. In this case, we don't have that information. So next we look at which primary trig ratio could we use. And based on this as the reference angle, 82 degrees, we label our three sides of the triangle. So across from the 90-degree angle is the hypotenuse. Opposite the 82 degrees, that's the opposite side. And the third side is the adjacent side. So in this case, we have information for the adjacent side, and we're trying to solve for the opposite side. So these are the two side lengths that are involved in our calculation. Which trig ratio uses the opposite side and the adjacent side? Well, that's the tangent ratio. We know that the tangent ratio for any angle is the opposite over the adjacent. So we're going to fill in the information from our triangle here. So in our case, the reference angle is 82 degrees. The opposite side is h, and the adjacent side is 30. Now we have an equation that we can solve for h. So in order to solve this equation for h, we multiply both sides of the equation by 30. And so here, 30 divided by 30 divides to 1, so I'm left with 1h is equal to 30 times tangent of 82 degrees. When you do this calculation on your calculator, be sure that your calculator is set in degree mode. So when we calculate this, 30 times tangent of 82 degrees is equal to 213.46. And because our initial 30 meters was here, because that was in meters, we know that our height for the building will also be in meters. So therefore, the height of the building is about 213.46 meters tall. Okay, here's our next question. Here we want to find an unknown angle. So we have a right triangle. So we know that our options of how we can solve for unknown sides or angles are either to use Pythagorean theorem or to use the primary trigonometric ratios that we have learned now. And because we're solving for an angle, Pythagorean theorem is not going to help here. So next we look at which primary trigonometric ratio could we use. So if theta here is our reference angle, okay, the side opposite that is the opposite. Across from the 90-degree angle is the hypotenuse, and the third side that's left is the adjacent. So again, we think about which trigonometric ratio involves these two side lengths, the hypotenuse and the adjacent. Well, that's the cosine ratio. We know that the cosine ratio for any angle is equal to the adjacent over the hypotenuse. So we fill in the known information from our triangle here. So the angle is what we're trying to solve for, so we're going to leave that as the unknown theta. The adjacent is 15, and the hypotenuse is 25. So now when we solve for an angle, we use what's called the cosine inverse. So when we take the cosine inverse, we isolate for the variable. So theta is equal to the cosine inverse of 15 over 25. And when you type this into your calculator, you're going to need to find the cosine inverse button. Often that is using the second or the shift key on your calculator. Usually it is the second or the shift function of the cosine button itself. So you should be able to find that on your calculator. So we take the cosine inverse of 15 divided by 25. And you should get an answer here of about 53 degrees. And because the question says we're rounding to the nearest degree, this is a rounded answer. It was actually 53.1301 approximately. And so we round it to the nearest degree of 53 degrees.